Hello, Professor Sargent here with you again. We're going to take a quick look at the method of least squares, also known as linear regression. I'm not going to provide explanations about why this works. I just want to show an approach that can be used. This may not be the approach that your instructor is looking for. So you should ask whether it can be used. And if it cannot, still, this gives you a way to check, even as you use the longer approach that they may be showing. We're told here that Moody's Corporation is the holding company for Moody's Investors Service, which has a 40% share in the world credit rating market, at least at the time of the rating. According to Consumer Reports, the total revenue in billions of dollars of the company is projected to be as follows. And we have information about 2004, 2005, etc., up through 2008. And the revenue, again, that's in billions of dollars. We're supposed to use x equals 4 to go with the year 2004, etc. So x equals 8 would be the 2008 here, and so on. So I got this out of a book, and I previously only assigned 2 parts here to come up with an equation, a linear equation for this, and then putting that equation in slope-intercept form. And the second part was to make a prediction for the year 2010. Now, as a note, in a statistics course, if this were, if we observed revenue for 5 different years, only between 2004 and 2008, in the second part, we're going to be asked for a prediction about the year 2010, which is outside the range of the years. That, in statistics, they call extrapolation, which is something to be cautious about. Generally, we should only be making predictions within the years, the range of years. So let's say that we had 2004 to 2008, but we were missing the information about 2007, for example. We can make a prediction about what that was, and then, well, all right. So I'm going to show a method using the TI-84, and again, you'd want to know if your instructor will allow its use. If not, well, at least you've got a way of checking when you go about using the longer approach. So let me fire up the TI-84 here. Be back in just a minute. All right, so on the TI-84, here's what you do to come up with the equation. Press the stat key. Go with the very first option. You've got 3 submenus. The first submenu is edit, and we're going with that one. The very first option there to edit. This would be similar to using Excel for any of you that are familiar with using Microsoft Excel. If you have previous data in there, go to the top of the column, not the first entry, but the very top, press clear, not delete, but clear, and enter. And I have to do that for 3 of them here. All right, so I'm going to put in the years. Actually, remember that x equals 4 corresponds to 2004. So we had years 2004 to 2008. 4, 5, 6, not 3, 4, 5, 6, 7, and 8. You should double and triple check that you type things correctly. 4, 5, 6, 7, and 8. All right, and then the revenue in billions of dollars, 1.42, 1.73, and then I've got to move this to see the rest. Let's see here, 1.98, 2.32, and 2.65. Double checking. Just press the down arrow and be back at the top. 1.42, 1.73, 1.98, 2.32, and 2.65. All right, all is good. So to get the equation, let's see here. Now press Stat again. Go to the second submenu, Calc, and choose number 4. LinReg AX plus B is going to tell you what A and B are. A is the same as M, the slope, and B is exactly as what you would expect, the y coordinate of the y-intercept. So I've got my information about X in list 1. I pressed second and 1. My information about Y in list 2. Don't need anything else. Scroll down and did calculate. So our slope is 0.305 and our y coordinate of our y-intercept is 0.19. So notice here that when I put it in slope intercept form, you've got y with this funny symbol over it, read as y hat. Y hat is a prediction of y, which may not match up with the actual values. In fact, let me go back to the calculator here. If I put in 4 for 2004, let's see here, 0.305 times 4 plus 0.19. That's giving me 1.41, when in fact, the observed value was 1.42. So the point here is that the 5 points that were given are not representing a perfect line. However, it should be coming pretty close to it. I'll show that in a minute as something extra. So in our second part, we were supposed to come up with a prediction about Y in the year 2010. Again, they have subtracted 2000 from these to get our X values. Remember, X equals 4 was the year 2004. So the year 2010 is X equals 10. And we're getting 3.24 there. So our prediction is 3.24 billions of dollars, or writing that all out like this. Okay. And I'm going to do one more thing here. If I press on the TI-84 zoom and 9 for zoom stat, we get our 5 points plotted. Notice they look pretty close to being on a line, but not exactly. I can get it to graph the closest fitting line. If I go back here, and this time tell it to store the equation. Oop. Messed that up. Quit. Stat. Calc. Choice 4. Vars. y-vars, function, and y1, what it's done is in the regular y equals menu, it has stored that equation. Also notice that I had plot 1 turned on, so it would plot the 5 points. How you get to that is second, y equals, to turn a stat plot on. If it was previously off, I would select it and press enter to turn it on. We would know that it's on by the highlighting. And to get it to do a scatter plot, it's the very first option. Okay, so I've already done zoom 9. Notice how some of those are a little above, some of them a little below, some of them might be right on the line. A little tough to tell unless I get a bigger view, but the points were not perfectly linear, and yet we've got the closest fitting line here. That's all I've got for now. I hope this has helped. If it has, stay tuned for the following message.